Hello, so let us solve the problem now. So we are supposed to calculate this indefinite integral. So if you have a little bit of experience of calculating the indefinite integrals, you probably realize that the best way to do this is the method of integration by parts. So in integration by parts, we have the integral of a function of x, say u, multiplied by dv. The answer of this integral becomes uv minus the integral when the roles of u and v are interchanged, v du. Okay, so this actually method of integration by parts reduces a given integral to calculating another integral. This method is always true, of course, but it is not always useful. It is only useful when the new integral is simpler to calculate than the original integral. And sometimes the wise choices of u and v makes the problem simpler, makes the new integral simpler to calculate. Okay? So here, for example, what we do, we have some choices. For example, I can take x to be my u, and then the rest of it should be taken to be dv. But if you look at the right-hand side of the formula, you also need to know v. So if I take this part to be dv, I have to do some work to be able to find v itself. So because of these considerations, this is not my first choice. So my first choice would be like this. I will take this one to be u, okay? And then the combination of these two, x times dx, I will call it dv. Yes? Of course, you have to practice something. You need to do some trial and error sometimes. It is inevitable. But here, it seems that this is a better choice than taking arctan of x dx to be dv. Why this is it? Okay, so let me start with my choice here. I have u, arctangent of x. When you look at the formula, you see that you need du here in the formula. So this motivates you to differentiate this. So the left-hand side becomes simply du. The right-hand side, the derivative of arctangent is a famous function. It's 1 over 1 x plus x squared and then dx. So this is my du. But I have assumed that x times dx is my dv. But you immediately realize that to calculate this integral using this formula, I also need v. So this means that I integrate both sides to get v. Okay, so the answer to this is also simple. It is 1/2 x squared plus a constant, but a constant doesn't matter here. You just need one integrand. So whatever you choose for the constant, it will work. So the simplest case is the simplest choice is c equals to 0. So now I have whatever I need. I need u here. I need v here and there. I need du here. Yes? So, and then I have, so I just need those three for the right-hand side. Okay, so I start. This is u, and this is dv, so the question mark is nothing except an integral of u dv. The right-hand side is u times v. This is my u, this is my v. I multiply them, so it becomes 1/2 x squared arctangent of x minus integral v, which is this expression. It's a factor of 1/2. I can pull it out, multiplied by du, and du is this. Okay, so if I want to write this a little bit more organized, so this is just 1/2 x squared arctangent of x, and then I have minus 1/2 integral x squared multiplied in the numerator, and then I have 1 plus x squared dx. Okay, so now in order to answer this question, I have to calculate this integral. But what type of integral is that? It's a rational function involved here. So a polynomial in the numerator and a polynomial in the denominator. So I have a rational integrand. I have an integrand which is rational function. And the degrees are also the same. So what I have to do something to make the degree of the numerator smaller. So let me give this a name I, and let me start calculating I here. So my I is actually equal to the integral x squared divided by x squared plus 1. That's just 1 plus x squared dx. So the trick is to do this. I add 1 to the numerator and subtract 1. And then I divide it by x squared plus 1 dx. So I have done nothing. I have added 1 and subtracted the same 1 to compensate for that, so that's exactly true. And then what I do, I will take this first two term and divide it by the denominator minus the second one divided by the denominator. So let me just write it. So this becomes x squared plus 1 divided by x squared plus 1 minus 1 over x squared plus 1, and then the whole expression dx. But then this one is just simply 1. So I might decompose this integral into two parts. Integral of 1 dx minus integral of 1 over x squared plus 1 dx. But both of them are actually extremely simple. This is just simply x, and then this is a famous function. Which function has the derivative equal to 1 over x squared plus 1? That is just simply arctangent. We actually use that here as well. So that is nothing except minus arctangent of x. Yes? And then when I is clear, I put it back here in this equation. So what do I have? It becomes 1 over 2 x squared arctan. And then I have minus a half times I, that is my I multiply it by 1/2 minus a half, it becomes, let me write that one first, it becomes 1 over 2 arctangent x, and then I have minus a half x, and of course I have the constant. So this is the answer to this integral. So this is the set of all functions whose derivative is equal to whose derivative are equal to this x times arctangent of x. Of course, you can always check it out by sitting down patiently and differentiate the function. Okay? Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.